Now I may need you to memorize these two formulas. These are called the ABCs of square roots. At the same time, you must be able to recreate the square root table like this one. And they are so easy to make since you only need to multiply a number by itself. 2 times 2 is 4. 3 multiplied by itself is 9. And so on. Now I call this one perfect numbers because their square root are easily identifiable. For example, square root of 9 gives you 3, a perfect root. Square root of 9 is 3, right? Square root of 4 is 2. If I take the square root of 4, I have a perfect root of 2. Square root of 16 gives you 4. Now perfect roots are easy to find. Just look at the table. Now how about the numbers in between? For example, you want to find the square root of 11 or 12 or even 15. I'm sorry, 15. In such cases, we turn to the formulas. Now if you look closely, this is just like filling in the blanks, where A goes in this box, B, and negative D sub Y goes here. While this one goes here, B, and D sub Y, and finally C, the solution, goes here. Well, what is A, B, and C? I'll tell you. A stands for the integer of the radical in question. Okay? Integer of radicand. B is the integer of the perfect number. D sub Y stands for the negative difference. And finally, C is the solution that goes here. I'll give you an example. Suppose I want to find the square root of 3. And I look down the table and see that 3 is between 1 and 4. Thus, the nearest perfect number would be 4. Now I have two data, square root of 3 and square root of 4. Watch how I use the data. So A stands for the integer of the radicand in question, which is 3. Thus, I would put 3 here. And B stands for the integer of the perfect number. So I will take the integer of this one, the perfect number, and put it here. Alright? Now what does B stand for again? It's the integer of the perfect number, which is 4. This is the perfect number, right? So 4, square root of the perfect number. Perfect numbers. Here. You will look here. And we will get negative 0.25. You will always get a negative number. And now that we found the d sub y, which is negative 0.25, we'll place it here, right? Because it says here, you have to place it here. It says in the formula. You just follow the formula. B is the integer of the perfect number, which is 4. And you process it, and you find 1.75. Now to check, you only need to multiply 1.75 by itself, and you will get approximately 3. Which is the answer. Now I will give you 2 more examples, and everything goes downhill from here. Now let's say that we want to find the square root of 88. Now looking down the table, I can see that 88 is between the perfect numbers 81 and 100. So I would need 100 as the higher limit. Always go for the higher number. As what we did in 3 here. We got hold of the higher limit 4. And now that we have the data, all we need is to fill in the blanks. Eight goes there. Get the integer 100. Get the square root of 100. All you need to do is copy this one and put it here, right? And you get negative 0.6. Moving on. You get square root of 100, which is a perfect number, 10. This will become 10, right? Place this one here, and you will get the answer, 9.4. The square root of 88 is 9.4. Now to check, all you need to do is multiply 9.4 by itself. Sorry. And you will get approximately 88. Decimal point. Now let's say 365. Let us find square root of 365. Moving down the square root table, we find that 365 is between these two perfect roots. Alright? So our higher limit will be square root of 400. Applying the formula, we get this one. Square root of 400. And you get the difference of 0.8. Negative 0.875. Moving down, and following the formula, we have square root of 400. We copy this one here, 0.875. That's negative 0.875, which will give you the solution C, which is 19.125. Now let's check again. The answer is correct. So 19.125 by itself will give you 365 This is what we're looking for. I'll give you one final example. Let's say 9525. Square root of 9525. Going down the table, here I see that 9525 is between these two perfect roots. Thus I will go for the higher limit, 9604. Square root of 9604 is 98, right? But you don't know it's the square root of 9525. So, we place this one here. And 9525. We place this one here. And the square root of 9604. So 9525 minus 9604 divided by the quantity 2 times square root of 9604 will give you negative 0.403. We bring this value here. And the higher limit here. Now 9604 It's easily identifiable here. It's 98. So this will be 98 plus negative 0.403, which gives you 97.597. I leave the check to you. You just need to double the number. So it should be approximately 9525. Oops, sorry. Approximately 9525. So please like, share, and subscribe so I can grow my channel. Thank you once again and have a good day.